number 11 here. It costs $625 to charter a 55-passenger bus for 4 hours. Which function will give you the average cost per passenger, right? So per passenger. So it cost us, the cost is equal to 625, and then we want to divide that by per passenger, right? So per passenger, passenger Y, right? X equals the number of people. So this is based, instead of cost, we're going to say Y equals, and then each person is X, so divide that cost by X. Okay, so now just kind of like the ending of the last one, we're not adding anything to this, so horizontal asymptote will be Y equals 0. But we're just asked to find out which relevant domain. So what can I plug in for X? Basically anything, right? Not equal to 0, but does it make sense to have negative passengers, right? Does it make sense to have negative passengers? No. So I'm not going to do these two, even though this one's completely wrong because it's X over that. This one has the right function, but it would normally be X cannot equal 0, but it doesn't make sense to have negative passengers, so we're going to throw that one out. Okay, so it only makes sense to have positive greater than 0, right? So which one? This one again is that one's messed up because it's X over 625, so we're going to go with this one. Makes sense to have 0, can't have 0, and then up to 55 because the max is 55, right? So look at the context of the problems for those ones when you're looking at your domain. Okay, so fill in the blanks. Okay, so we're looking at this equation, and so we want to factor it to see our horizontal asymptotes and our vertical asymptotes, and if we have an oblique asymptote or a point of discontinuity. Okay, so remember, mostly looking at, let's do a horizontal asymptote first. Okay, so horizontal asymptote first. We look at the degrees. That's an x squared. This is an x squared, so they're both the same. So it is y equals lead coefficient 1 divided by lead coefficient 1. So that'd be 1 over 1 equals y. So this has a horizontal asymptote. So it has a horizontal. So it has a horizontal asymptote. Okay, so then we can go to the next part. This graph, does it have a point of discontinuity or a vertical asymptote? So that's when we set our denominator equal to 0 and kind of solve it. But we factor it first, so we could cab this. So cabbing would be a -4, and our b is 0, right? So that'd be an x minus 2 and an x plus 2. So then we would set those equal to 0, and we get x equals 2 and x equals -2, right? So we can't have those two, so we would say those are vertical asymptotes, right? But we do have to check, maybe it's a point of discontinuity. So we factor the top. So if we cab the top, that'd be a 4 and a -4, right? So factoring that, that would be what times what is 4 but adds to 4? That would be 2 plus 2, but I need a -4, right? So that means they both need to be negative. So that'd be an x minus 2 and an x minus 2. So now that the top has an x minus 2, and the bottom also has an x minus 2, that means that these would cancel, right, if I was simplifying. So that means that at this one, at x cannot equal 2, is actually a hole there. There's a hole there, which is called a point of discontinuity. So a hole, so it's a hole at x equals 2. Oh, so let's actually go down to this one. At x equals 2, we actually have a hole there, which is called a point of discontinuity. That's a hole. Point discontinuity. Okay. Now at x equals -2, nothing canceled, right? So this one right here at x plus 2, we would get an x cannot equal -2, right? That didn't cancel. So that since that didn't cancel, that means we have a vertical asymptote there. Cool. So what you do is you factor top and bottom, and if you have like factors and they get a cancel, that means that one on bottom that got canceled is actually a point of discontinuity. So make sure you look at what it says at these 2 points, because I had to switch mine. I had to put my hole on bottom because I was talking about x equals 2. All right, number 13, graphing. So graphing, we can do just those two same things, right? We can look at our horizontal asymptote. So we look at the degree of the top, the degree of the bottom. Those are not the same. The numerator power is bigger, right? So that means there's going to be an oblique asymptote. So that means I actually have to do long division here. So x minus 2. What times x minus 2 is an x squared minus 3x plus 3. All right, so I say what times x gets me an x squared? That's just an x, right? So I distribute that x to both of them, and I get an x squared minus 2x. And I subtract those two, so that would be subtracting x squared, but adding 2x. And so I get left with a negative x plus 3. So then I ask myself, let me switch colors. What times x is a negative x? So that'd be negative 1, right? And once I ask that, I can just stop because that is my oblique. That's a linear function on top, x minus 1. So x minus 1 is my oblique, okay? So that's my oblique asymptote. So oblique, however you spell that. Okay, and so I can graph that, right? So that would be a negative 1, and then I go up 1 over 1 for my slope. So it should look something like that. So maybe that one would be okay. This one looks maybe up 1 over 1. So that one kind of looks real close to it. Right here, up 1 over 1. Or I guess those are counted by ones, right? So that'd be here and then here, right? So that kind of looks like it. And then this is also counted by ones. Now that one doesn't because it hits it, right? So it's somewhere between these three. So we know it's not that one. Now we can set our denominator equals 0 and we get x cannot equal 2. But is that a hole or is that a vertical asymptote? I would be looking at these pictures saying there's no hole on there, so it's probably not a hole, but you could factor the top and get an x. That's not even going to be factorable. What times what is 3, but adds to 3? That's not possible. So you can't even factor the top. So x cannot equal 2, so we go 2. It kind of looks like it hits right there. So probably not that one. This one, it definitely hits right there, right? So it's not those two. So it'd probably most likely be this one right there. Okay. So find those vertical asymptotes. Look for the horizontal. If not horizontal, you have to do long division. You can stop right there. So I don't even need to finish this over here doing long division. Once I have that linear equation on top, I'm good. Okay. All right, then we have Aiden, who walks 1 mile at an average pace of 25 miles per hour, then walks X more miles at an average pace of 20 miles per hour. Here's our function that represents Aiden's average pace in minutes per mile. Can we figure out a horizontal asymptote? Okay, so we look at the degree of the top, 1, degree of the bottom, 1. So it's just y equals coefficient of the numerator, lead coefficient, divided by the lead coefficient of the denominator, so we get y equals 20. Okay, Aiden will have to walk a total of at least how many miles for his average speed to be at most 22 miles per hour? So what that means that we're doing is just taking this and setting it average pace at most 22 miles per hour, right? So at most. So this is his average rate, 20x plus 25 over x plus 1. And we want that to be at most 20. So we don't want to go over 20, right? So at most, so or equal to 22. So then just solving this, or we know it can't be -1, which makes sense, can't go -1 miles per hour. All right, so then just solving this, how do we get rid of dividing by x plus 1? Well, we multiply it by x plus 1. Okay, so then we have 20x plus 25. We can get rid of this inequality. We come back and test it. Equals 22 times x is 22x, and then 22 times 1 is 22. So then solving this, we subtract over 20, right? So then we get 2x on this side, and then here we subtract 22 on both sides, and we get 3. So 3 halves. So our number is 3 halves. And looks like they already did the work for us. Aiden will have to get a total of at least 3 halves. So normally, if you were solving this equation, you would test a number to the right, bigger than this, so plug in 2 and see if that's correct. Okay, so we plugged in 2 here, that'd be 40, 60, 65 divided by 3, which is what, 21 point something, and 21 point something is less than 22. So that is correct. Okay, so we can go at least 3 halves. Okay, now we have number 15, y varies, so that means y equals k. And then jointly just means multiplication. Jointly as x and z, so that means we're multiplying by k both by x and z. And now we're just solving this equation for k. So they're going to give us some numbers here. Sometimes you have to decipher what to put in, but they're going to give us 3 numbers, y, x, and z, in order to solve for k. So they say, and y equals 72 when x equals 4 and z equals -6. So then solving this for k, we can just divide by 4 times -6, which is just -24. And what isn't that 3? -3. So k equals -3. So k equals -3. So I can write my equation y equals k, which is -3 times x and z. Now they say, what is the value of y when x is -5? So that'd be positive 15 times 7 times z, 7. So 15 times 7 is 105, right? 15 times 7. Yep, 105. So y equals 105. Now you could set this up as a proportion. You could solve it for k, and you could say, okay, k is equal to y over x and z. So that's what k equals. And then, so then I could plug in my y, x, and z right here. Y, x, and z. And then I can set it equal to this one, y, x, and z here for that k, because k would equal the same no matter what situation. K stays the same. That's why it's called the constant of the variation. So you can always set your k equal to k, meaning I can set, let's get a little more room. Now you can't even see it. That's great. Now I can set that equal to y1 over x1 z1 equal to a second y over a second x and a second z. So you can set up as a proportion and solve it that way if you wanted to. So I can set this equal to y over -5, 7, and solve it that way as a proportion. So there's 2 ways that you can solve number 15 there, and you'll still get 105 as an answer. Okay, number 16 says y value varies, so y equals k. And inversely, that means divided by x. All right, so here you can solve it for k if you want to. I'll set this one up as proportion k equals y times x. So that means no matter what y or x I'm given, it should equal the same exact k, because it's the same. It's constant of the variation. It's the same, remains the same each time. So they say y equals 10.2 and x equals 3. And so then what is y? So what is y when x is 2? So I can just solve this equation like this, because this is giving me a k, this y and this x is giving me a k, and this y and this x of 2 is also giving me a k, and those k's need to be the same. So you can set those equal to each other, divide by 2. So 10.2 times 3 equals whatever, 30.6. So k equals 30.6. In this case, should equal 30.6 as well. So I divide that by 2. So that y is 15.2, or 15.3, sorry. 15.3. Okay, but you could solve for k, and then you could plug k into this equation, y equals k 30.6 over x, and then you could be given an x as 2, and you could plug that 2 in right there, and you'd get y equals 15.3. So you can do the same Same thing as that. Okay, so either way you can set up as a proportion, set your k's equal to each other, and then you could solve. Just write this down, how we got that y, just for those that are just looking at the answer key. Okay, 17. I'm matching up which ones go with which, okay? So I'm looking at this graph, determining which ones go with which. So I'm just saying, okay, at 25 miles per hour, what should it match up with? What time should it match up with, right? So I'm looking at this inverse variation equation and seeing that's 20 and 60. So at 20 miles per hour, this is 60 right here. So this is 60, a little bit lower than that. So if I want to see at 25 miles per hour, where should I be at? 25 would be right here, correct? So that'd be almost exactly close to 50. So which one of these is the closest to 50? That would be 48, right? So 48 minutes at 25 miles per hour at 48 minutes. Now at 30, okay, we're somewhere between what? This is 25 right here, right? So it's more than 25. So this one might be close, more than 25, so we can get that one more than 20. So it's probably 40, right? When we look at our choices. And then at 60, we're way out here. That's somewhere probably close to 25, right? So that'd be 24 minutes. Maybe 20. Let's take a look at that. So, oh, never mind, that's 55. 60 would be out here, right? 60 would be out here. So since 60 is out here, we can't really see, but we can see that 55 is more at 25, right? Maybe at 24. So 60, which would be right here. Let me get a different color. Maybe somewhere a little bit lower, right? So that'd probably actually be 20. Okay? So we're just evaluating that graph and matching up our x's and y's and estimating it a little bit. 18, so you want to get your LCD. So how do you get rid of dividing by x minus 2? Don't we multiply everything by x minus 2? So we're going to multiply everything by x minus 2. So let's put this LCD more maybe over here, LCD. So I want to multiply everything by x minus 2, right? Because then they get rid of that, right? But how do I get rid of dividing by x plus 3? Don't I also have to multiply by x plus 3? Okay. Then how do I get rid of dividing by 2? I would have to multiply by dividing by 2. So the first fraction I have to multiply by all three of those things. Then the second fraction I have to multiply by all three of those things. I'm going to run out of room here. 1 over x plus 3. And this last one, 3 halves, I have to multiply by all that as well, right? I have to multiply that by, where am I going to put it? Multiply by, we'll put it down here, 2x plus 3 and an x minus 2. So that would be my LCD, right? 2x plus 3, x minus 3. A lot of times it's all your denominators, usually. If you have any multiple factors, so sometimes if you have a quadratic down in the denominator, you have the factor, right? And so if you have same factors, you only list it once. Okay, so this one's going to cancel, right? So no more fraction. We just have to FOIL this out. All right, we get 2x squared plus 6x. That kind of looks like an A. All right, and then this one, the x plus 3 is going to cancel. So then we just have 2x minus 4. So plus 2x minus 4. And then here, only the 2 is going to cancel, right? So there we have 3 times this quadratic here, right? So we get this quadratic. And let's go ahead and switch colors. And so we get x squared, so a 3x squared. I'm going to pause it and kind of move this over a little bit. So then we get a 3x squared, and then x times negative 2, and then 3 times x, so that'd be 1x times 3 is a 3x, and then 2 times negative 2 times 3 is negative 6, negative 6 times 3 is negative 18. Okay, so then we're just solving this one. So we subtract our x squareds over, so we subtract our x squareds over, and we get a, we're just going to set this side equal to 0. That is an 8x, right? So we can combine those two to get an 8x. Subtract that over, subtract the negative 2x squared, so we get x squared minus 5x, add that 4 over, and we get negative 14. So what times what is negative 14 but adds to negative 5? That would be an x minus 7 and an x plus 2. Divide by a, which is 1, so that's going to solve anything. And then set these equal to 0. So we get x equals 7 and x equals negative 2. So 7 and negative 2. Okay, last two problems. So this one we set on a number line, which they kind of already have for us, so that's nice. So we set our denominator equal to 0, we get x equals negative 1, but it can't be that, right? So it can't be negative 1, so that means it has to be an open circle, so like that one, or this one, or this one. So that means we can get rid of this one, right? Because it can't be negative 1. Okay, now we just solve this like an equal sign. So multiply both sides by x plus 1, right? And those would cancel. Multiply this by x plus 1. So we get an x minus 3 equals 5x plus 5. Set this, solve this linear equation, right? So we subtract x and minus 5, so we get minus 8. That doesn't look like a good 8. Minus 8 equals 4x, so x equals negative 2. But can it equal negative 2? No, because it's just a less than. So it just should be open circle at negative 2. So this one's good, this one's good, but this one's not, right? So it's between these two. So we just test in between. So we're going to go ahead and test a number in between negative 2 and negative 1. Well, that's not fun, because I don't want to pick a fraction, a decimal, right? So I want to test a number maybe outside, like 0. So I'm going to test 0, and I'm going to see if 0 works, right? So I'm going to plug in 0. So we get 0 minus 3 over 1 is less than 5. So it's negative 3 less than 5. That is true, right? So true. So we tested 0 and it's true, so that means this one is correct. Okay. All right, and the last one we're working with a work problem. So we have rate equals 1 over time. And so we have two rates, and an experienced painter can paint a room in 7 hours working alone. So one rate would be 1 over 7. When an apprentice helps, they can paint the same room in 4 hours. Approximately how many hours would it take them? Would it take the apprentice working alone? So we don't know how much the apprentice is working, so 1 over t, but they work together and it'll be 1 over 4. So just solving this, we multiply both fractions by t on this one and this one by 7. So then we get a common denominator, so we get t plus 7 over 7t equals 1 over 4. Then we can just solve for t, multiply that 4 across, so we get 4t plus 28. A equals 7t, subtract 4t, subtract 4t, and so we get 28 equals 3t, divide by 3, and there's our answer, 28 thirds, which is 9.3 repeating. So there you go. That's questions 11 through 20.